We're live. We are live. It is 10:52. I wanted to come on today and talk about. We had a few questions in the comments in recent live feeds where people were talking about boost, and there's some misconception about what's going on when we add boost, basically relative to RPM. So, excuse me, people think that when we add boost to something like with turbos, particularly, I think is the most common misconception. When we add a turbo, that hey, like we can rev it out more. Yes and no. We have talked about this many times. When I do a turbo something or other, do a turbo LS or big block Chevy or whatever it is, and as long as we can get the turbo to add the same amount of boost, like have it be wastegated to be 7 pounds or 10 pounds or whatever it is, two things are happening that would confuse people. One, the first thing is that whatever the NA curve is, wherever it made peak power, if you have a consistent amount of boost, it just does that curve again. So it's the same thing. It's just making a lot more power. And I think that that's where the confusion comes, because if you had a 454 big block or an LS and it made peak power at 5,500 and then kind of fell off, well, if it was making 400 horsepower and falling off, it feels different than if it was making 600 horsepower and it fell off. It would still feel like it's pulling really hard, because if you just look at the relative distance between the two, even if the power curve shape is the same and it's still making power at the same peak RPM and then falling off, but it's still falling off having way more power than it had before. So it pulls like it has an extra 200 horsepower there, because it does. But the shape of the power curve, where it makes peak power, if the boost is consistent all the way through it, where it makes peak power does not change. And so that part of it is the same. But the trickery there is that, hey, look, we're making a whole bunch more power. So now it pulls a lot harder because it has a lot more power. That's understood. The other thing that can happen, and this happens with the other forms of force induction, can happen with a turbo. If we have a rising boost curve, let's say that you don't have control of your boost and it runs from, 10 psi and rises up to 12 or 15 psi, you'll get the same kind of curve that we get with a centrifugal, which is the thing that I want to talk about. If you have a rising boost curve, then you are going to change the shape of the power curve. You're going to change where it makes peak power. I'm going to show you an example of this, on a 347 Ford. So you'll be able to see how big of a change we made and how big of a change you can make. Even, you can exaggerate this with, way more boost and all that. You can also change where the thing makes peak power by putting a positive displacement supercharger on it. And the reason for that is when we go from our NA combination, whatever it is, and put a roots blower or some sort of positive displacement blower or Kenny Bell or Whipple, that kind of thing. What normally happens when we do that as part of that putting the blower on procedure is the lower intake manifold is going to be a shorter runner, particularly if you're housing an intercooler underneath the blower, which is common. But even on a typical 471, 671, 871 kind of thing, 10, 12, 14, whatever you're talking about, when they mount those blowers, the manifolds that they mount those on more often than not is some very, very tiny short runner thing with just a common plenum underneath the blower. Blower's just pushing all the boost in there. You got immediate boost, you got a big blower, you got all the torque that you can usually manage. That's not a problem. But when you go from a long runner NA deal to that, irrespective of the boost, you're first changing the power curve because of the manifold. So the short runner manifold is going to want to make power at a different RPM than the long runner manifold does if you had a long runner manifold to begin with. Now, if you already had that, just ran it with that manifold on there with a carburetor on there, a plate or whatever, then you could get a back-to-back kind of thing. But that short runner manifold is going to do that. The other thing that happens in the one that I want to talk about today is actually with a vortex supercharger. So a centrifugal supercharger. There are others, Torque Storm and ProCharger. But if you take a centrifugal supercharger, it makes, in all of the tests that I've ever done, it makes less power at 2,000 RPM than it does, let's say, at 6,000 or 7,000 RPM. So the faster that you spin it, the more airflow it has and the more boost it'll produce. So it has a rising boost curve. So the boost curve goes up with engine speed. as we talked about before, if you have a rising boost curve, when you do that, you're going to artificially increase the area where you have more boost relative to less boost. So you're making the motor, in a sense, more efficient on the top end, where it's producing all the boost and where it's adding all the airflow and where it's making all the power. If you look at where a centrifugal supercharged application makes peak power, more often than not, it's at whatever the peak engine speed is. So if you run your thing to 6,500, you'll have the highest boost at 6,500. The exception being is if you get belt slippage, which is not good, or if you simply run out of supercharger. If you have maxed out that supercharger and it can't flow any more air, even spinning it higher, you're usually getting to the point where you're probably going to damage the impeller because you're over speeding the blower. But if you get to that point, it can kind of level off and fall off. And then it follows kind of the power curve, because now you have probably a falling boost curve. But if we have everything set up so that we have a rising boost curve, the blower is able to support whatever this power level is, and it certainly was able to on this combination. I can kind of demonstrate to you what happens. What we did was I did a test where we compared a 302 to a 347, and we compared it with all the stock stuff. So we ran a 347 with stock 5-liter E7TE heads, the stock HO camshaft, and I think we put a GT40 intake manifold on this. And then we didn't do the HO, but the HO would have been way worse. It would have been even lower RPM stuff because the HO would have limited power, and even more so on a 347. So as restrictive as the intake manifold and those factory cylinder heads and the factory camshaft is on a 302, and it is, we know that we get big power gains when we change those things. It's even more restrictive with more displacement. So on a 347, to give you an idea, when we ran those things on a 347 Ford, it made 306 horsepower at 4,700 RPM on a 347 with all that stock stuff. And then 400 foot-pounds of torque at like 3,300. That's as low as we loaded that motor. It probably could have made more low-speed power. Then we put a Vortex supercharger on it. I think this was an S trim or an SI. It had enough superchargers. I mean, we only made 400 and something horsepower. So we weren't running very much boost. We weren't spinning it very hard, but we had way more blower than we needed. So it was not a problem. We put a Vortex on it and it made 8 pounds of boost, like I said, at the horsepower peak. So it didn't make 8 pounds of boost until 5,700 RPM. Down at 3,300 RPM, it made 2.4 pounds. So it rose from 2.4 up to 8 pounds of boost on this 347. On this 347 with a stock cam, stock heads, and the GT40 intake manifold. When we did that, the power went up, the horsepower went up from 306 horsepower when it was NA to 421 horsepower when it was supercharged. And torque went up from 400 to 461 foot-pounds. In both instances, we increased where the motor made peak horsepower and peak torque by 1,000 RPM. In fact, it made peak torque, not quite, about 700 or 800 RPM higher. And then on the horsepower, we went from making peak power on the naturally aspirated combination with those restrictive parts on a 347 at 4,700 RPM. That's where it made peak power. And after that, it rolled over and fell off. Because like I said, all of that stuff is very restrictive on the 347. And as we go up in displacement, we would continue to shift that back a little bit. At one point, we would just stop making more power and just make more torque down low. So we made 306 horsepower at 4,700 RPM naturally aspirated. When we had the supercharger, when we had the Vortex supercharger on there, it made 421 horsepower, but at 5,600 RPM. So we changed it by 900 RPM. That's where we shifted peak power to, just by the fact that we were adding boost at a rising rate with this centrifugal supercharger. So it goes to show you that when you do that, I mean, you can't say that, hey, all blowers do this or all turbos do this. They don't all do that. They can do different things. but you can shift where you make power. And so you can basically, with the centrifugal supercharger, and I did this on my Mustang that I drove around for years and years and years, you could increase the effective RPM range of your motor. Now, some would argue that the lower boost down low is, detrimental, and you want 10 pounds all the way across like a turbo gives you. And having ridden in both of those kinds of vehicles and driven both of those kinds of vehicles, the turbo obviously accelerates better, because anything that has 10 pounds of boost at 3,000 RPM and 10 pounds of boost at 6,000 RPM is better than one that only has it at 6,000 RPM. We know that that's the case. Notwithstanding, the centrifugal blower, the Vortec that I had on my Mustang, I ran 3 different versions. I ran the A trim, which is the first one that they introduced, and then I ran the B trim, which was the upgraded version of that same one, and that was serial number 001. So it was the very first one that they did. And then I also ran an R trim on there, and I don't think I've ever run any of their later trims when that motor was in the car, because I'd run that around for years and years and years, and then took that motor out and then started testing at Westech decades ago, and did a bunch of testing and wrote a book and did all kinds of stuff with that. But the Vortec stuff was cool. I naturally have run lots of their blowers on the engine dyno and all sorts of things, not just Fords, but big block Chevys and small block Chevys, LSs, Hemis, you name it. They have kits for all that stuff. So, and lots of different size blowers, all the way from their A trim, which we did originally, which I'm sure they no longer offer, but all the way up to some of the Mondo blowers and things. I haven't run in any of their like V series racing blowers, because I just haven't ever had a motor that needs that kind of thing. But obviously they're catering to that market and can make big power. But if you put a centrifugal supercharger on something, we've run them on Hondas. I did some Bonneville stuff with those. On the Civic, it works good. On the B series motor, it worked good. If you want like top end power, quite honestly, on a Honda, I would rather have more mid range power, which is why the turbo stuff works so good. But we did go very fast with the Vortec on a lot of the Honda stuff, so that worked out good. In fact, we made our own drive setup for the supercharger for a Vortec on the Honda. My buddy Bernie fabricated one up that bolted to where the AC compressor normally goes, because we weren't ever running that. And then we made a cog drive and all that, so that we didn't have to worry about belt slippage and the big transfer shaft and everything they did. But I drove around a lot of those cars. I had one on my Del Sol with the transfer shaft and all that stuff, and this, it worked out fine. But it worked good. But know that, so you can change the effective RPM range of that. So if you want another 1,000 RPM or whatever, you put a centrifugal supercharger on it. Now your 5,000 RPM is a 6,000, or your 6,000 is a 7, and away you go. Let's see what you guys got going on here. Supercharger. Okay, would you pick a Vortec centrifugal supercharger over an NA motor to run more RPM? It should run also more power, because that's definitely what's going to happen by a lot. We know that that's the case. Greetings, Winston. Jet is in the house. Yo, Sean. What would be a safe boost for C9 heads on a 460 stock internals? I think it would depend more on the tune, but certainly I ran around with my Mustang at 7 or 8 pounds without any problem. You probably get away with more than that, as long as the tune is right. And are you running pump gas, and is it intercooled and all that stuff? Ask Turbo Central how much boost he runs on his. Chad, what's going on? Eric, Adam, Aussie Land. Safe PSI is a PSI you can support. The stock internals don't worry me so much on the 460. Just put ring gap in it, and then you could get away with a lot. We haven't frozen yet. Yo, Frey, send me. I have a couple questions for you. Send me an email about the transmission for the Metro, and for the sprint. Richard holding the rules. I know, but you got to spell the name correctly, though. There's another E there. Danny, Jeffrey, Richard, stock LY6, bottom end, 823 heads. Good. Considering milling the heads. Would it be fine? Piston valve clearance with the truck plus can. Yeah, you got miles of clearance. You got nothing to worry about there. What's the purpose of a CO2 bottle on a turbo engine? That's usually for controlling the wastegate. So they're putting dome pressure on top of the wastegate to hold it closed until you actually want it to open. Can also be done with boost, but some guys like that better. What if the turbo isn't fully spooled by the time you hit the RPM? You would have been at the NA power peak, like if your turbo is a bit too big. Yeah, then you don't have a consistent boost curve like we talked about. Then you have some sort of rising boost curve rising past wherever this RPM range is. Would love to see an NA on 80% nitromethane, 17% methanol, 3% toluene. I don't know about that last part of it, but the nitromethane is certainly possible. Apply pressure to the top of the wastegate so they allow more boost than just the spring pressure. It allows for more tuning. Yeah, you get more precise control and more like dynamic range, let's say. Come on, Rich. Huge injectors, huge pump, thick piston crowns, and body armor. What do you say? What do I say about what? Oh, the nitromethane thing? Yeah, no, I want to try nitromethane. I've wanted to for a long time, ever since I saw that Cletus video. Should I go to 1071 or 1471 on my Pontiac since the 671 won't keep up? You just have to decide how much power you want to make. Which one of those will do that? A good 671 is 1,000 horsepower. So do you want to go past that? Looking at doing a rising curve versus RPM and boost by gear for the G10. I think that's probably a good idea. There are some instances like we talked about with a rising curve, like a centrifugal does. In fact, guys are really successfully using that stuff in drag racing because they don't have traction. I mean, if you don't have traction, there's no sense in having way more torque than you can possibly harness. Sticks and stones. I have a 6-liter Summit Big Nasty Cam. Can I run hoses from both valve covers and run them to a tri-port catch can and use one port as a breather? Do I have to have a line going back to the intake vacuum port? No, in fact, I don't like drawing crankcase back into the intake. We just exit it out. We have it vented to atmosphere. So the catch cans are a good idea, and don't run it back into the intake manifold. If you've ever looked at the inside of an intake manifold that has a lot of miles on it, like a truck intake manifold, it's full of oil, and you don't want to do that. You don't want to breathe in oil because it will detonate much more readily with oil vapor. Did you take attendance yet? I didn't take attendance, but you are here. You're one of the 73. You can switch insurance to Geico. The Gecko. Whatever happened to the Chevy Metro? We're still doing it. We already ran the AMR on it, but I'm getting another AMR, and then I'm going to compare that to the turbo. I have a 6-liter sub. Okay, there we go. Why doesn't anyone make a cheap centrifugal supercharger? I thought that Speedmaster had done. I thought that I saw like a Vortec copy thing, but I've never seen a completed one, or I've never seen one tested. And a Torque Storm is pretty affordable. Thumper's right. Swapping Vortec brackets now. Custom 351 bracket. Hopefully I can take K-member spacers out now. Okay. We just used the 302 brackets, and I think that we may have re-drilled it or something for running on a 351. I know that we did that on the we put a Windsor setup on the Cleveland. I don't think that way. Low RPM isn't my goal. Voted no. The Vortec by itself isn't going to do that. Let's see. Isn't going to do what? Would you pick a centrifugal supercharger over an NA motor to run more RPM? Oh, okay. Well, what we were talking about is making peak power at a higher RPM. Maybe I didn't phrase that properly. But adding the Vortec to your NA motor will have it make power at a higher engine speed. I'm more than happy spinning the 427 to 7300. Yeah, but you have 100% boost lag on that because you don't have any boost. I like to stay under 6500, preferred 6000. Means I can use the less expensive valve train. Valve train stuff is not cheap. If you go to get T&D or Jessel or something like that, that's real money. Sent you an email message on Facebook. Okay, I'll check it out. I want to know if I can use what transmissions I can use because I want to put something together to run at Bonneville. Look into pump gears and sprockets on sale site for Coyote is a must for Coyote with any kind of power to live long. Just picked up and already have them. You're talking about oil pump gears? There's no dumb questions, Gabe. I probably shouldn't. I probably should know this. Does a small block Chevy and big block have the same width of water ports? I'm looking for an electric, and a guy had one for sale. No, an electric or a small block and big block pump are not, water pumps are not interchangeable. The spacing's different on, and the size of the openings are different too. We have a big block pump and a small block pump that are different from Mizir or CSI or whoever we have them for. And the factory ones are like that too. So they are different. Mr. Dino, just want to let you know I received my lifters today. All right, Bobby, great. Yeah, Jimmy's on top of stuff. He said thanks again to all you guys who were helping with him working on the site and stuff. 73 people and 5 likes. I know, really. Right now we're at about 33%. It's 75-25. So you prefer to just vent crankcase to atmosphere? Yes, that's what we do on the dyno. Every motor that I run on the dyno is like that. All the LSs. I just have a valve cover that I use. And now I have 2 of them because I have the cool the cool double fancy, which is way more than I deserve. BTR valve covers, which have AN fittings on them. And then I have AN fittings. I think that they're 90s. And then hoses that go out and they just go back behind the dyno. We could put them to another catch can or whatever, but doesn't really need to be because the motors that we're running, the 5.3 has a little bit of blow by, but most of them don't. So not an 80% dead AMR. No, the AMR probably was okay before I ran it on, before I spun the snot out of it on the LS. Probably would have worked at low speed. Torque storms make great power and are very affordable. Yeah, the torque storms are good centrifugal superchargers. They were good. The Chevy guy long enough that it's embarrassing to ask. It's the only research I've come up with it. Oh, no, that's good. It's weird because some of the big block and small block stuff do interchange, but not all of it does. Hood won't shut with the 302 bracket. Okay. Adding the Vortec blower to my motor will prevent me from being able to drive it on pump gas. Yeah, probably so. B&R Thumper wants you to put an 871 on there. Is there a difference in long-term life between your low buck truck and the truck Norris? Cam and other valve train components? No, there wouldn't be any difference I don't think between those two. They're just too close together in terms of power and RPM and stuff. Also, which of those is better for torque in a 2.5 to 4.5? You wouldn't see a difference between those two cams. You wouldn't be able to measure it really. You'd see them wiggle around 1 or 2 foot-pounds or whatever, maybe kind of about what the range would be between even just doing one run to the other run. So there's no bad choice there. One of them just is just less money. TPI versus TPIS mini RAM with boost. I missed the torque of my 406 TPI. The mini was not as snappy, short runners on the street, but ran much better number at the track. I don't need to do another guy's test. I've already done TPI versus mini rams, and we know what they do. A mini ram just makes more power on the top. That's why you were able to run. If you were able to go quicker at the track, it's because you were using higher engine speeds. But the mini ram does lose power compared to any of a tune ports, a stock one or modified ones, and then it does the same thing under boost. That none of that changes. I'll give you an idea. Tune port shootout. Okay, so there's the mini RAM. Let's compare that to the TPIS. So a modified version of a TPI, with a ported runner and stuff. This was a TPIS one with the big tubes on it, but same length as the stock one, and just a port matched upper, but then a ported lower. Made more power than the mini RAM up to 5,000. And then the mini RAM made more power from 5. We ran it to 6,500. Made more power from 5 to 65. But to give you an idea, at 4,000 RPM, 57 torque with the mini RAM was 457. This was on a 383. But torque with the long runner was 533. So it's a lot. I don't see, like, in this comparison, even if we ran this thing to 6,500, I don't see where the unless your gearing was so spot on that you ran from 5,000 to 6,500, I honestly don't see how I don't know if the mini RAM would prevail in that. On a bigger motor like a 406, there's more of a lean toward the shorter runner stuff, only because you already have lots of torque just from displacement. Billet oil pump and sprockets, OEMs shatter. Yeah, I never had a problem with my Coyote with them shattering, but mine was a Gen 1 that we did all the testing on. And we ran it to, I think we ran it to 8,500. But I have heard the oil pump stuff. For a front-wheel drive street Civic, would it be better to have a Vortex supercharger than a turbo to preserve traction? Do you have a traction issue with a turbo? I don't know. If it's for street, I don't think you're ever in a position where you're just launching with everything that you have in first gear. I think it's more so guys on the street rolling on at 2 or 3 or 4,000 RPM. It would just be better with more torque. Really wanting to run Holley HP on a K24A1, but can't do VCT without a module. Do you think you could use adjustable cam gear setup to make up for the mid-range performance loss from the VCT? No, I don't think you. I think you're going to trade, which is what variable cam does. Well, what variable cam eliminates the need to do. You don't have to trade by one fixed position. No matter where you put it, you're going to trade something. You're going to trade something at the top. You're going to trade something at the bottom. You're going to trade something in the middle. That's the nice thing about having the variable cam. Have an 871 coming from Frisbee. We'll see how it works when the snow and salt are gone. The nice thing about the snow is it's really good. It's really good blower weather. The traction thing, not so much though. Do small block Chevy handles boost like an LS engine? Not like an LS engine. I'm getting a standalone ECU, but it would be nice not to have to swap the motor. You can run boost on a small block. So it depends on how much power you want to make. But yeah, we've run boosted small blocks a lot. I have no shop and nothing that can haul a 55-gallon drum. I was looking at Manton rockers, but don't want to mortgage my house. Were you looking at those for your 1 liter? That's what I thought. The guys had a Mazir. I was advertising that fit both, and I called BS. Yeah, we have a big block and a small block version of those. And if you look on their site, I'm sure they'll show different ones. Can you do pump gas with 11.5? You can with the right cylinder heads and octane and, well, pump gas if it's 91 or 93 and just the right timing. Because Speedmaster has one under 700. It says up to 1,070 CFM and 22 PSI. Richard, when installing back pressure sensors, does it matter where it's located in relation to the wastegate? Well, I don't think you want it right next to the wastegate, because if you have it right next to the wastegate, you're going to get a change in back pressure when the wastegate opens and closes. Maybe you want to see that, but we put the back pressure sensor. You can put it, like, we tried a bunch of different places because we wanted to see if there was a difference in back pressure in different spots. But we have it, I think, on the I think we had it right before the turbo in one of our positions. And then also we have a 90-degree elbow that goes up and where the turbo mounts on. And we have it on the intersection between the exhaust and the Y pipe. I have a Procharger on my 97 Silverado, but it seems like it doesn't make that much boost. Do I have to change the pulley to make more boost? Yes. And what I'm talking about is a reality, regardless of whether it's a Procharger or a Torque Storm or whatever. They make less boost down low and then more at the top. Every centrifugal supercharger does that. It has to. So where you want your, what you want that boost rise to be, what you want the starting point to be and the ending point to be, you just pulley for that. And then obviously for your octane and for your timing and whether it's intercooled and all that. Does anyone make an intake for a 1471 Pontiac? Does a 1471 require a different intake than an 871 or a 1071? I've seen snow before, half an inch of it 10 years ago on a Thursday. Bigger is better, but may surge at idle. Scrolling. I've seen that snow stuff on the news. Looks like it drops the IQ of drivers. Well, rain also does that here, Dan. I was battling traction issues with my C4 Corvette, 700 R4, so the loss of torque was actually beneficial. There you go. Always have traction issues with turbos. Dan, around here, only the Southerners can't drive in it. We use the snowpack roads. That's a 60-mile-an-hour highway to people in the Upper Peninsula. I know. I don't know what the big deal is driving in snow. We lived in Tahoe for a while, but even just driving up there it's just kind of a normal deal, especially in a front-wheel drive car. I love driving up there in the little front-wheel drive cars that I had. I'm like, hammer down, man. Let's go. Snow drifts. I think a centrifugal would be great on a big block where we already have so much torque down low. Yeah, a lot of guys are using that, like I said, for no prep stuff. It's kind of a form of traction control. Cold in Arizona. What is it right now? It's 60 degrees here right now. 10 psi at 1800 RPM. Yep, you got traction problems. It's a balmy 22 degrees here. Working on my tan. There you go. I love the F2 Procharger on my small book Chevy. I run an engine 7500 with a Procharger. It's going to like it up there. Ran the same engine NA for several years. Ran it to 8,000. Man, rockers look expensive. 5 psi, 2500, 10 at 3, 15 at 3500. Traction is a real problem. How much practical difference does 91 versus 93 octane really make on the dyno? It doesn't make any power change difference. But what it does is it will allow you more timing. So, and we see that in California, if you run a car on 91 where the motor is in the car and running hot like they do, not hot, but at an elevated temperature that we don't run on the engine dyno. So if you're running at 180 to 200 degrees, let's say, most times on a street car or truck on 91, you can't run all the timing in it. And so 93 will allow you to run more timing in it. And then therefore you can make more power. I don't think even maybe on 93, you can run all the timing in it. I just don't know. I don't have enough experience with that. And to know what the knot counts would be under different conditions, but you can definitely run more timing with 93 than 91. If you get E85 at the pump, is it considered pump gas? I consider it pump gas because we have it from the pump right around the corner from West Tech. So that's where I go get it all the time. Delete the VVT on a 2003 Silverado LS build or keep it. If you keep it, you're still going to have to limit yourself, because if you're going to make more power, you're going to have to put some kind of camshaft in it. And if you put a dedicated VVT cam, a VVT performance cam, which people have, more than likely you're going to, at the very least, have to put phaser limiters on it, so it limits the amount of swing that you have, because you have a bunch now, with most of that happening not at wide open throttle. Most of the swinging that's going on is happening at lower engine speeds and lower loads. So you get rid of that. So you're not just getting rid of what happens at wide open throttle, you're getting rid of what happens a lot during the drivability portion of it. I would be interested to see somebody do a test to find out what the fuel mileage change was from that, to see if that's happening. And if you get a big enough cam, they just have to eliminate it. I have to pull out timing to run 91 versus 93. Yep, that's pretty normal. I consider E85 from the pump to be pump. Yeah, that's right. See what you did there. Richard, how do you feel about electronic boost control versus manual boost control? They both work. They just do things differently. A manual controller is just a simple bleed valve, or what they were doing. I've been going back down the Dodge Omni rabbit hole again. What they were doing on those, which I never did. I never tried this. We would always use a bleed orifice. The cheapest way was just to get an aquarium valve that allowed some of that bleed to go out. The problem is, on a mass air carb, that's a vacuum leak. But the way that they did it is the Granger valve has a check ball and a spring, and you don't bleed anything off, or you don't allow the signal going to the wastegate to happen until you get past the whatever that spring rate is. And so it doesn't open the wastegate. Basically, you're kind of putting a secondary wastegate spring in there, but in line of the vacuum reference. So you can trick that into doing it, but with no leak, though, because there's no leak on the other side of it. It doesn't know that there's an opening, because there isn't an opening until you press the ball against the spring. It's kind of cool. I was unaware of that until I started reading about all of the Dodge stuff. They're like a Granger valve. I'm like, what is a Granger valve? Is that just a bleed valve that they got from Granger? That was my immediate thought. And then after reading about it, I'm like, because somebody was telling me about it, I'm like, but that's not how bleed valves work. And they're like, no, you need to look at this. I'm like, oh, okay. I think I understand it now. I can't wait for boost, but life says I'm going to wait for that paycheck. There you go, Frank. I'm lucky I only got to go 15 miles to get pump gas in Woodland. My G10 is a cam on bucket like your XFI. I was looking at them for the LSX. I'm going to run Jessel. Okay. Wow, Jessel, that's big. How are you determining you can advance timing and or need to remove some? How much extra time you can use with 93 versus 91? It's going to be a couple of degrees minimum. 1471 Pontiac V8 blower intake is definitely one off. 671 and 871s are made. So you're not just extending the back part of the rotor housing, right? They extend the opening that it blows into too. Testing on a chassis dyno and looking at the knock sensors. Yeah, or you could just look at knock counts on the street too. Snow isn't the problem. Ice is. Yep. Traction was my thinking behind using your Truck Plus over the low buck truck camshaft on the project. Okay. I don't know that that's going to be an issue, but will electronic boost controllers work on a centrifugal supercharger? No. The only way that you could apply that is if you put a wastegate on the discharge side, like on the boost side, and put a pulley to spin the thing way up, and then just opened up some of that so it's not blowing into the motor. And guys have done that, but that's not a good idea. I mean, I guess it is a good idea if you want to do that. Texas Speed 427 LS3. Nothing will make more power than E85. It should, and it has on dedicated, like very high boost race motor stuff. I just don't know what it does in the range that we're talking about. Like if you run 10 pounds and you run it NA, you run it with boost, pump gas at 10 pounds and you run on E85 at 10 pounds, because I would think E85 and methanol are probably going to have the same amount of maximum timing. So I don't know if the methanol all by itself at that low boost does anything. Kind of like E85 doesn't do a lot on an NA motor that's 9.5 to 1 or whatever. It just like NA, it just doesn't make that much of a difference. I wonder if we see the same thing with methanol, but that's why I want to test. I've considered buying a gas station. That would not be cheap, right? Working on my E85 cold start calibration this week. I need 450% cranking fuel for 25 to 30 degrees. Got it springing to life now. So you need that big accelerator pump shot. Looks like I cut my nose there when I was shaving. Stepped a little too close to the razor. Got it springing to life pretty nice now. Good. 25 degrees. We like that. That's real cold start stuff, right? With my cam and Procharger, your fuel mileage got better? I never heard of that. I'm using a Mac valve on my build, Danny. Good. 6.8 1071s have the same size opening, but the 1471 case length is so long, there's no room for a regular distributor. I figured that. I figured it overhung that. I mean, we see that just on some tunnel ram stuff. They put a crab cap on it or an offset distributor, or just we usually just solve it with a crank trigger. Kind of helps. Richard, you don't think electronic boost controllers improve response by pressurizing the top of the gate until it's time to bypass? Yes, I think that they absolutely do that, but they don't improve the boost response of a turbo. What they do is change the small area of boost when the boost is coming up to the gate and the gate is starting to open up. Like, let's say you wanted it, if you have it set for 10 pounds, you have a 10-pound spring in it. Well, maybe it's opening up a little bit at 8 pounds and a little bit at 9 pounds and a little bit at 10 pounds. And so as it's coming up, then it will open up, and having boost on the top of it, like having a 3-port or whatever, will hold that closed. So in that little range, there is improvement. But the problem is when you tell people that electronic controller improves boost response, they think that it improves it way down here. And it doesn't. It doesn't do anything down here because the gate's completely closed. So where the gate is completely closed, there's no change in boost response. There's only a change right in that last little bit. $14.71 is what they use in top fuel. I have to pull 12 degrees and 15 psi to run 93 versus Q16. That doesn't surprise me. Any budget friendly non-turbo options for small block Chevy? For what are you talking about? What are you trying to get done, dude? And whatever it is you're trying to get done, you don't want to use a turbo on it? I'm using wastegate, blowout valve, and bypass valve on my supercharger to keep boost under control. Yep. You're using you're not pulse width modulating a blowout valve though, right? How do you have a wastegate and all that on there? A wastegate, a blowout valve, and a bypass valve on all of those? It may be no issue for traction, but torque steer can be tricky with 300 horsepower on a front wheel drive car. Yeah. Thanks for going live. We're here for you, Jeff. Have you tested centrifugal versus turbo? Controlled to match a centrifugal curve. I don't know what you mean by controlled to match a centrifugal curve. You want to handicap a turbo so that it only makes 2 pounds down low and 10 pounds on top or whatever. 1471 designation, just extrapolated from 871 size rotors. Jim never made a 1471 yet. Procharger at 10 psi and GT500 injectors got my highway mileage to 38 in my 3.7 Mustang. Okay. Sean, back to work. Okay, go try to make your truck stop thing work, your fuel station. Yes, like a centrifugal or roots boost. So why do you want to change the shape of the turbo curve for a centrifugal? A roots blower doesn't have the boost curve that a centrifugal does. It doesn't have very low boost down low and a bunch at the top. A roots blower has more down low. And then sometimes, depending on what size the blower is and what the intake manifold is and the combination is, and what the flow rate potential of the blower is, sometimes you can have a slightly rising curve with that. Putting a low buck in my NA daily. There you go. I said no because boost doesn't help RPM. It just helps make where you make peak power. Discrimination. Also, I'd worry about trading belts trying to run ridiculous RPM with Superchargers. One of the things that the centrifugal guys don't understand, and I don't think that they will admit, and that's unfortunate because I like I said, I had a Vortec on my thing for like 85,000 miles. But no matter how fast you spin the blower, like no matter what size pulley combination you put on there, oh, we got to spin it up because it's going to make 25 pounds at idle. It never does that. It can't do that because of the multiplier effect. So at 2000 RPM, no matter what you do to the pulley, it's never going to make the boost that it makes at 6,500 RPM. It's not going to do that. And you can never, no matter what pulley size you do, you can never make, like, let's say we have 2 pounds and 10 pounds. You can never get this 2000 RPM to be 10 pounds. You'll never get, well, the other one's going to be, if you do that, you're going to raise it to 20 on the other side. So you can never get those equal and have the boost curve be straight across. It won't do that. Also, I worry about trading belts. Yeah, Richard, I was wondering if you have ever run the sloppy stage 3 cam. Yeah, I have a video up with sloppy 1, 1.5, 2, and 3. It's cold in Florida, 40 degrees. So if the engine runs out of volumetric efficiency at high RPM, the blower or turbo is going to give it wings and let it fly. It's get a red bullet. It's making more boost than the bypass valve can remove. That's not unusual, Supra, because if you look at a bypass valve is designed to operate under cruise conditions, not under max boost conditions. And so if a bypass valve is this big, you're like, yeah, that's not going to restrict the blower. How important is crossover size, velocity versus volume as it relates to turbo lag? Very minimal. I'm going to buy a 4-inch pulley. That should fix the problem. It will if you slow it. You got to slow it way down. Good to see you. Nice use of emojis there, Ralph. Just wait until I put a 24-inch pulley on my crank. There you go. What you want to do is you want to do that on a centrifugal where you're also driving all of the other accessories so that you overspeed everything else. Overspeed the water pump, overspeed the power steering, blow up the power steering pump, overspeed the alternator, all of that stuff too. Matt, smashing them chicken Safeway. Ooh, Safeway chicken strips. I don't think I've had those. Why stop at 24? Just get a wagon wheel. Well, then everything will just be gear driven. Just have them touch. Have the blower wheel and the crank wheel have all those pulleys just touch each other. Then you got a Pete Jackson blower drive. 5-speed motorbike gearbox for the supercharger. I have a stock 302 small block forward. The one, and so I think somebody mentioned it. The one way to get around that is if you spin the blower independently of the motor. So you spin it up with an electric motor or whatever I think guys are talking about. And you can do that. So then you have the blower RPM that you would normally have at 6,500 RPM. You can have that at 2,000 RPM. Then you can have all the boost that you want. Then it could be whatever boost curve you want. If you can control that electronically, that's one way to do it. It seems like a lot to go through, and when you could just put a turbo on there. But I have a stock 302 small block Ford, 5-speed, 7875, a 3-pound spring in the wastegate, electronic boost controller. Off the turbo scroll, I've only been able to make 3 pounds on the 2-step. Would CO2 help? Can you see if the wastegate is opening? The wastegate shouldn't be opening. And have you tried putting a more spring in it? or just taking the reference line, take the reference line off of the wastegate, or just put the reference line onto the top of the wastegate only, and then see what it does. See what kind of boost you put on the two-step. See if that's the problem. See if the wastegate is opening. If you put reference pressure only to the top, it won't open. You'll have all the boost and the spring pressure all working together. If you have any boost, you'll have all of that working against the gate opening, or just put a cap over it so that you know the wastegate doesn't open, and then see what it does on the two-step. That will tell you what's happening with the turbo and whether or not that's spooling up. Yeah, Mad Max AC clutch. If you go to Harbor Freight, you can get a 420 engine and mount your supercharger and the engine on the roof with a gearbox. There you go. You could do the boost caboose like the Freiburger did. 1400 horsepower cold air supercharger, 8500. Those are really good. Then you don't even need intercooling. What happens when you overspin a centrifugal supercharger on a regular basis? You will break the bearings, or sometimes make the wheel touch the housing. Yours is 2-to-1 right now, Centra? Yeah, that's a lot for that blower size and that motor. Aluminum L98 hits from a Corvette or Vortec iron heads for boost. It doesn't matter about boost for either one of those. The Corvette heads are going to be smaller chamber than that. And I don't think that an L98 Corvette head flows as well as a Vortec head. So I think that the Vortec would make more power, but the aluminum head helps with detonation. That might be a coin toss on that one. Good explanation of the response improvement of a 3-port electronic controller. Yeah, it just holds it closed so that it's closed the whole time until 10 pounds is reached. And then when 10 pounds, then it goes happy. Otherwise, it's like, I'm going to open a little bit and then a little bit, and then all the way. And you can see that when we do those boost controller combinations where we have pressure on the top, when we do that, you can see it in the curve, because the curve comes up, the turbo starts spooling up. It's got no boost. It's got some, and then it starts going. And then when you have the 3-port or whatever on there, it goes like that and then goes straight up, and then to 10, and then makes a 90-degree turn. It's much better. So in that little triangle there's more power. And sometimes it's a lot. It's particularly with, I've seen some OEM applications where you can get the bypass valve also opening up, which is not good. Wouldn't running an electric supercharger result in more parasitic losses due to converting the mechanical energy to electric and back, as well as losing electrical energy to noise? Yeah, I don't know how they're getting the power for whatever they're driving on the electric motor for that. So that would be problematic. And also if it's separate, I don't know how they're driving all that. If you can outsource the power for the electric drive, then you could get rid of some of the parasitic loss associated with driving the blower. But in a car, I don't know what they're doing with that. That's like a big alternator situation. I know there are issues adding boost to stock bottom ends with tight ring gaps. Is there a way to help prevent some of those until you can replace the rods and pistons? Yeah, you just take it apart and file a ring gap into it and put it back together. Just use those pistons and rods and pistons. Just use the stock stuff like we've done on all the Big Bang motors. You just take those stock rings out and grind them and put them back in and put the motor back together. Have you done dyno tested 0-20 versus 10-30? Yeah, lightweight oil can add power. It's not going to be a lot. You really need to gap the rings. That's right. A little more boost, and then a little more boost, and a little more boost. It could work well on a hybrid if it used regenerative braking to charge a cell that powers a supercharger. And I would argue on a hybrid, because of the voltage of the hybrid batteries, that if you could get that conversion, you could have an electric motor that's not running off 12 volt or 110. It could be 440, 20 phase, or whatever these hybrid batteries are. Just using the bypass valve, it makes 3 psi in the charge pipe at 1,000 RPM and 20 at 4,500. Okay. Then the bypass valve is sized well enough for the flow rate of what your guys are doing. I need to look at, because I remember we did some stuff like that with the Kenny Bell, and opening the bypass valve was like the valet mode. And I think it dropped it. I want to say it dropped it 5 or 6 pounds or something. Anybody selling an inexpensive roots blower for a small buck Chevy or an LS? Yes. If take a look at the videos I have up, David, and thank you very much, on the M90 supercharger. You can go get those in Wrecking Yard for like $100 or something. But it's never cheap because you have to get lots of other stuff to make it work. System is very computerized and sensitive, so who knows what problems it would cause. Yeah, no, I know. That would be the logistics of that. The control circuitry would be problematic, but cool if you have all of that, excess voltage. Bypass valve is 38 millimeters. Yeah. Turbo Central, what size is your crank pulley and your blower pulley right now? And what RPM are you running? Ever seen the F1 style of turbos with a 2-foot long shaft and the engine's V with the hot side of the back and the compressor on the front, the hybrid motor in the middle helping to spool it? That's pretty cool. Well, because they want it spooled up all the time, not just based on exhaust energy. Use 112s or 12s or 122s can be found. Yep. Seeing some cool hybrid mods back when I had a Prius. The modifications you can do are limited. You can't just put a Kenny Bell booster pump on them and call it a day. Probably need to run electric supercharger at 48 volts. I think that they are. I think that they're really high voltage stuff, not 12. New 85 reduces intake temps, but my understanding is it actually burns hotter than normal gas. So would ring gap with the 85 normally be more or less, or basically it's just the same? And I need to go back and look at my data. I'm pretty sure the EGTs are lower on E85. Prius and cool should never be used. What if one is sitting outside and you could say, look, that one's cool to the touch? Crank is 6 and a 275. Yeah, that is small. Can't recall your website, or it's richardholdnerperformance.com. .gov.org. Did I spell that right? I think I did. There we go. Boom. We have stuff on sale right now. Tell them Richard sent you. If you want to run motor DC at high power, then you need to build a 120 volt DC battery bank. Then use a standard inverter from your 12 volt and rectify the output. See, Robert the electrician. In that case, it's either warm or cold. It's the on-off hybrid switch. Happy to help, Tim. Easiest, least expensive way to DIY it I could think of. I think that that's what they're doing. I think that they're running the electric supercharger stuff temporarily, like for short bursts, and then recharging some sort of stored voltage at a higher than 12 volt rating. I think what you're talking about is exactly right. To me, it's cool, and it's a neat way to get around. Like I applaud everybody trying to do stuff like that. Whether or not you needed to do all that rather than just put a turbo on there, I guess guys could argue about that. How's our poll doing? Looks like we're pretty split. 52% saying yes. Put the centrifugal on there. I didn't phrase that right. It should have been better than that. I can tell you, P.D. Cunningham used it successfully in the Vortex Supercharged NSX in World Challenge. Interesting. What the heck is going on? Yeah, I'll be on tonight. It's interesting. I think that the most popular live feed I did is when we were talking about Tony's test. So I need to hang out with Tony more, obviously. A lot of hybrid ECU stuff is locked through, unfortunately, so you need your own hybrid power controller. I remember when we were doing the Jetta hybrid with the guys from Volkswagen with the Bonneville setup that we did with them for them. We said, okay, we got the car now. We're taking it apart. They said, okay, you can't take anything apart until we get there because it's dangerous to work with the hybrid battery. We're like, well, the hybrid battery has already been taken out and thrown across the shop. So that's not an issue. Oh, you guys unplugged it? We're like, yeah, we just unplugged the big lever and plug that came out. And then we took the battery out. We went threw it on the shop floor. It's fine. There's nothing wrong with it. Oh, you guys shouldn't do that. Or I said, well, we're doing a Bonneville project and we cannot wait for a week or whatever till you get here to tell us to wear gloves or be grounded or whatever you're going to tell us. We got this. Okay. We have to start welding on this thing today. And we were not going to wait. And we were not going to weld on it, obviously, with the battery hooked up. And we were not going to have the battery there while we're welding. So we needed to take care of stuff. Biggest obstacle to overcome is making the startup current for the electric motor. Get a bunch of capacitors and then throw them at the people in your shop. Get your XJ now before Tony buys them all. What XJ is he getting? You would need some kind of separate charging just for the supercharger, separate battery, alternator. Yeah. I get it. Or, hear me out, or like a $400 or $500 turbo. Turbos, blowers, all of that. All that works good. Well, hello. What did you get? Did you go steal something? Let me see what's in your mouth. Let me see. You're good? Are you good? Come here. Hello. Say hello. 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 That's Bruno, huh? What are you doing? What? Oh, big stretch, huh? Big stretch. Hello. 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 you were definitely sleeping, weren't you? Oh, I just woke up, Daddy. I had a tough day. I slept all night and then woke up and then ate and then laid back down. What a good life it is to be a puppy. You know, a small engine connected to an M90 is the form factor of a small electric generator. There you go. We don't talk about Bruno. We do, huh? We do. Where's your brother at, huh? Where's your brother? Is he downstairs? I know what you guys need to do. I know where you need to go, huh? Daddy, it's sunny outside. We're doggies, huh? We need to go see if there's any deer or squirrels or any of those outside, huh? We do. We do. Okay, I will see you guys all. Easy there, mister. I'll see you guys all tonight. Tonight. Whoa.